Students, this is Miss Yu. I hope that you've all been doing really well this whole week since you've been out of school. I really miss you all, but I hope that you're staying safe at your homes, making sure that you're staying home and not going out so that we can prevent this virus from spreading. I really hope that we can see you all again in school soon, but in case that doesn't happen anytime in the coming weeks, I do want us to make sure we can continue learning about thermal energy. So I'm going to go ahead and post more videos, hopefully, that go over the lessons with you more clearly in case you've had any more questions as we were learning. Alright, so first I want to show us our Schoology page and make sure that you all know how to access what I've been posting. So every single day of this week I've been putting up a post, and you can see them here on the screen by going through the updates. Something that's better for you all is if you actually click on your course, and if you go to materials, I put up Monday's assignment, Tuesday's assignment, Wednesday's assignment, as well as Thursday's assignment. So let's go ahead and start by pressing Monday's assignment. So over here it says, number 1, learn the 5 vocabulary words by viewing the Unit 6 vocabulary words. Number 2, practice the vocabulary words on Quizlet. And number 3, answer the vocabulary quiz questions. So you can either click on these links in the correct order, or you can click over here. So I'm going to first go over the Unit 6 vocabulary words that you should have been practicing, hopefully throughout the week. So I will open it up with Google Slides. Now there are 5 words that you need to know for this unit. We're first going to start with the word, once it loads, number 1, particle. So the first word I want you to learn is the word particle. A particle is a small piece of a whole. So for example, all that means is imagine a solid block of ice. You know that ice is made up of water, and water is a water molecule that's made up of particles. Now particles are small, the smallest part of a unit of a whole. So think of these are called atoms. So when you have small particles or atoms that join together, you have molecules. And when these molecules all come together, you have your object here, which is the solid ice. So again, particles are just a small piece of a whole, and water particles make up water. That's one way of using this word. Now moving on to number 2, kinetic energy. Kinetic energy is the energy of motion. So when you are running or riding a bike or walking around, you have kinetic energy because you are moving around. Kinetic energy basically is how much energy you have as you are moving. So when you think about these particles, in a solid state, these particles are not moving that much. They are not vibrating that much. So you would say that these particles have low kinetic energy because their kinetic energy is not high. They are not moving around that much. However, when these particles start to vibrate more and more, when they start to move around more and more, you're going to say that the particles have high kinetic energy because they're moving around faster. So again, kinetic energy is the energy of motion. When particles are moving around fast, they have high kinetic energy. And when particles are moving around low or slowly, they have low kinetic energy. Now number 3, temperature. Temperature is the average amount of kinetic energy of the particles. So what that means is imagine all of these particles over here. These particles are not moving that fast. They're moving relatively slowly. So on average, the particles here have a low temperature because temperature measures their average kinetic energy, how fast they are moving. So when it is cold outside, that means that the air particles are actually moving around slower than average. So then that means that their temperature will be lower. So if it's cold, like 60 degrees, 50 degrees, that's measuring how fast these particles in the air are moving around. However, when you have a hot sunny day and the temperature is very, very high, like 90 degrees, 100 degrees, that means that the particles in the air are moving around a lot faster. So these particles have higher kinetic energy. So on average, the temperature will be higher because their kinetic energy is higher as well. Moving on to number 4, thermal energy. Thermal energy is the total amount of kinetic energy of all the particles. Now, I know this one, some of us confuse this with temperature. They sound very similar. The only difference is the word over here, total. So, kinetic energy measured the average kinetic energy of every particle, while thermal energy measures the total amount of kinetic energy of all the particles. So, if you look over here, both of these orange juice containers are 40 degrees, so their temperature is the same. That means that the particles in both of these containers are moving on average at the same speed. They have on average the same kinetic energy. However, this bottle of orange juice has less thermal energy. And why is that the case? Well, this one is a lot smaller, which means that this bottle contains less particles, while this carton of orange juice has many more particles. So if you add up all of the individual particles in this container and how much kinetic energy they have, it will come up to a greater total than the particles here because this one is a smaller container. So again, even though these two have the same temperature, this container of orange juice has more thermal energy because there are more particles in this container. Now, one more to hopefully help you understand this concept. Thermal energy is the total amount of kinetic energy of all the particles. So again, you have a cup of hot chocolate and it's 100 degrees, while you have a pot of hot chocolate which is also at 100 degrees. So in this case, again, the particles inside the hot chocolate, they are on average moving at the same speed. They have on average the same kinetic energy. That's why the temperature is the same. However, this pot of hot chocolate is larger. There's more particles in this one. So this one would have a higher thermal energy versus this smaller cup of hot chocolate. Because remember, this cup of hot chocolate has less particles in total. So when you add up all of the particles to kinetic energy from here, it's going to be smaller than all the total of kinetic energy of particles from this pot. Hopefully that makes more sense. Now, last word, thermal energy transfer. Another way of saying thermal energy transferred is saying the word heat. So when you feel heat, you're actually feeling the thermal energy that is moving from one place to another. So transfer means movement. So when thermal energy is moving from a hotter area to a cooler area, that is called thermal energy transfer. And that's when you actually feel heat. Like we've learned, when you touch a hot object, then your hands will feel heat because thermal energy is moving from the hot object to your hand, which is the cooler object. So something really important to remember about this is that thermal energy will always transfer from a hotter area to a cooler area. So heat always moves from hotter to cooler. Now, I uploaded this concept map to hopefully help you understand all 5 of these words. So if you look here, heat is the movement of thermal energy. So when thermal energy is moving, that's what you call heat. Now, thermal energy is the total kinetic energy of all the particles. And thermal energy depends on temperature. So if the temperature is higher, the thermal energy will also be higher. And also, temperature is the average amount of kinetic energy over here. So temperature is the average amount of kinetic energy. All right, so those are the 5 vocabulary words that you should know for this unit. You will be seeing these words throughout the lessons that I post, so please make sure you study them. If you wanted more practice with these words, you can go to our Quizlet link. And when you click Quizlet, you can go ahead and practice like you've done with the flashcards, or you can also play the match game or the gravity game, your choice. Okay, but moving on, I'm going to go ahead and show you this demonstration to help you understand these words a little bit better. So all of these little dots that you see here are particles, and right now we're looking at neon. So these are all atoms, neon atoms, or we can call them particles. And when I add heat, when I add thermal energy to this scenario, let's see what happens to the particles. So as heat is being transferred into the particles, you notice that the particles are moving around a lot faster. So if they're moving faster, that means that they are now having a higher kinetic energy because they are moving around faster. And if you'll notice the thermometer, it's measuring the temperature, and the temperature is going up and up and up as these particles are moving faster and faster. Because remember, temperature measures the average kinetic energy of the particles. It measures how fast these particles are moving. Now, what would happen if I start to place ice cubes underneath? So now these particles are starting to lose thermal energy, and they're starting to slow down, so their kinetic energy is decreasing and they're moving a lot slower. So as these particles lose thermal energy, you notice that the temperature is also decreasing. The temperature is decreasing because the particles are not moving around as fast. So you can go ahead and I'll put this link up on Schoology. You can use this and play around with it. You can also do it with oxygen atoms or with water molecules and see what happens. Alright, now moving on. So the last part was to answer the vocabulary quiz questions. So if you were to press that link, it prompted you to write your name. So hopefully you typed in your name. I'm going to go ahead and type in my name as a demo. Now again, it says before you take the quiz, make sure you did the following first. So hopefully you read the 5 words and you practiced on Quizlet. Now if you're ready, you can press next slide and go ahead and take the quiz questions. So definition of particle. We learned particle is a small piece of a whole. So when you press submit, it should tell you that's correct. Next question. Definition of kinetic energy. Remember, that's the energy of motion, how fast or slow the particles are moving. So kinetic energy is the energy of motion. Next question. Temperature. Remember, temperature measures how fast the particles are moving on average. It measures the average, not the total, but the average amount of kinetic energy of the particles. So on average, if the air particles are moving slower, then that means that the temperature will be low. But on average, if the particles are moving faster, then the temperature will be higher. Number 4, definition of thermal energy. Remember the orange carton and the orange bottle? We said thermal energy is the total amount of kinetic energy of all the particles. It's when you add up all of the particles together, their kinetic energies, that will give you the thermal energy. Now, definition of thermal energy transfer. Transfer means movement. So thermal energy transfer is the movement of thermal energy from a hotter area to a cooler area. Alright, number 6. Now what happens to temperature when thermal energy is added? Well, going back to our simulation that I showed you, what happens to thermal energy when temperature is added? Let me reopen the simulation. So we saw how when you add thermal energy, in this case, fire is adding thermal energy, what happens to the temperature? Well, the temperature is definitely increasing. It's going up as thermal energy is added. So let's go back to our question here. So when temperature is added, where did it go? There it is. When thermal energy is added, the temperature will increase. Next question. How does the movement of particles change when thermal energy is added? Well, again, when we are adding thermal energy, how does the movement of the particles change? Well, they are starting to move a lot faster. So then you can go ahead and press. When thermal energy is added, the particles will move faster. And last question. If the particles are moving faster, how do you describe the particles' kinetic energy? Well, if they're moving faster, like you can see over here, the particles are moving a lot faster, how would we describe their kinetic energy? Remember, kinetic energy tells us how fast they are moving. So if they're moving fast, that means that they have more kinetic energy. So if the particles are moving faster, the particles have more kinetic energy. All right, so once you press finish questions, you should have pressed submit and it says you're done and your results were sent to your teacher. Great. So that was Monday's assignment. So hopefully you understood the 5 vocabulary words. If you ever want to review them again, please go ahead and press the links and practice on Quizlet. Some of you might want to retake the vocabulary quiz to get a higher score. I have been updating your grades on Schoology, so please go ahead and do that if you need to. All right, thank you for listening and thank you for following along. I'll post another video going over Tuesday's assignment and then Wednesday's assignment. So stay alert for my updates. Hopefully you have access to these videos. Until I get to talk to y'all again, if you have any questions, you can always message me over here. Press new message. You can type in my name, YOU, and then you wait for it to pop up. It takes a while. But once my name pops up, you can click it and you'll be able to send me a message, hopefully. So there you go, Miss You. So then you can go ahead and type science and whatever kinds of questions you can have, please message me and I'll make sure to reply to you. But until I get to talk to y'all again, stay safe, stay indoors, and please continue checking Schoology and getting all of your work done. Remember, even though I don't get to see you all, we still want to keep learning and make sure that we are practicing our science. All right, I'll talk to you guys again soon. Have a good rest of your day.